Um, okay, the V series. So this is D&B's latest line array. There's quite a lot of kind of individual things that make up why this product is so special, we believe. I'll concentrate mainly on the top boxes because the sub is, we think, pretty remarkable and pretty clever in itself, but it's kind of building on the generation of the B4 sub that we actually entered into the award ceremony a couple of years ago. So the top box, the V8 or the V12, this is a three-way passive design where most people are building new line arrays and kind of getting more and more control over how these line arrays are working and how speakers are working at different frequency bands, and using more DSP technology and more amplifiers to gain control. We believe we've kind of done that, but without the need for more amplifiers. So one amplifier channel drives all the three different sections of this array. So if I give you just a kind of inside view of how this looks. This is the inside, where we have two 1.4 HF drivers in there, which should be able to just pop these out. Those are the HF drivers on a waveguide, nothing new there, it's what we've been doing for quite a while. Then we have a 8-inch mid-range driver, and this is where we start handing over from driver to driver, where it starts getting difficult for us, because we need to make sure that the drivers hand over in a way that the drivers work nicely together, that the phase response from driver to driver is correct, but also making sure that the dispersion pattern is controlled, because we want a loudspeaker that has as broadband pattern control as possible. So in a V8 it's 80 degrees wide, and we want it to be 80 degrees wide from the highest frequency down to as low a frequency as we can get. So in the HF world, this is where we designed the horn to control the sound and disperse it however much we want it to. And then we hand over to an 8-inch driver here, and the 8-inch driver actually comes out of two different ports. We force it out of two exits, which travels either side of the HF, and it gives us a dipole. And what that does is when I stand over here, the sound from this dipole arrives after this one and kind of cancels it out to an effect over here and turns the level down, whereas in front they arrive together. So we get an amount of control off to the side from this arrangement. And then from the mid-range driver, we hand over to the two 10-inch drivers. And the 10s, if I pull this out, there's one of the 10s there. They're sat in another arrangement that gives us a dipole. Now, because these are doing a lower region, a lower frequency, to get the same control of 80 degrees, because it's a lower frequency with a bigger wavelength, we need the dipole to be sat further apart to control those frequencies. So we've pushed the exits to the very extremes of the cabinet to get us pattern control down to 250 Hertz, which for a cabinet this size is pretty remarkable, that we're controlling all the way down to 250 Hertz. And all of that is driven off one amplifier channel. Now that gives us quite a lot of issues. If I just show you on my iPad, which is nicely fallen to sleep, this is a picture of the inside where we have the two HF drivers, we have the mid-range driver in the back and two 10-inch drivers. So first off, we've got the HF that comes out the part in the middle. Then we've got the mid-range driver, which comes out of these two exits here as a dipole. Then we've got the two LF drivers. But the difficulty with the LF drivers is we need to make them combine nicely with the mid-range driver in that crossover region. But they're actually sat in different physical places. The 10-inch drivers are sat further forward than the mid-range driver. Now, doing all of this time alignment, usually this is done in DSP, in an amplifier. But we can't do this in this one because we wanted to make this a three-way passive box. So we have to come up with a new way of aligning these drivers. And what we've done is we've actually tuned the 10-inch drivers radiating into a small chamber in front of the driver, and in the back of the cabinet it's radiating into a big chamber, and it's a double bandpass arrangement. And we tune that bandpass to effectively give us the group delay or the timing delay to move that 10-inch driver back in line with the mid-range driver. And it's kind of building on the technology from the B4, but applying it in new ways to top boxes. And through this kind of technique, we've managed to align the whole cabinet so that its all phase response is good in all the different crossover regions, but also to give us a pattern control from all the way at the top down to kind of 250 hertz and keep it 80 degrees wide. Off one channel of an amp, that's pretty spectacular. Whereas a lot of people in modern line arrays are building line arrays where you might have 5 or 6 different amp channels in one box. One channel of an amp drives 2 cabinets. Some of the other things we've done, again, building on our experience with the J series, just pull that out so it doesn't fall out. One of the key things you want to do in the mid-range when you drive a speaker hard is you need to get the heat away from the driver. If you let heat build up in that driver, it causes power compression, and you can hear that in the way that the mid-range will sound. In the J series, we bonded the mid-range driver to the rigging on the back of the cabinet, which acted as a big heat sink. Now we couldn't do that in this box, but we wanted to do the same thing to allow the speaker to be driven hard, but be able to do it sounding nice effectively. So what we've done is, you can see here, the mid-range driver is actually in a complete concealed unit. The whole kind of tuning of the chamber and everything is all built into that one driver, enclosed in a housing, and on the back of this housing is a heatsink. So the heat from the driver is dissipated into the housing of that chassis, and then the 10-inch drivers are moving air backwards and forwards through this region in the back and passing the air over these fins, which effectively cools it down. And then that air is coming out of these ports here. So again, we're using acoustical design, acoustical engineering of the cabinet, not relying solely on DSP, but really getting into the engineering of the box to fix all the issues that we have. We have a 3-way box with huge amounts of pattern control for a cabinet of this size down to 250 hertz, which is remarkable. It's one channel of an amp drives 2 cabinets, and it gets its heat out in pretty clever ways in how it does that. Couple that to the fact we have a cardioid sub as well, where again, one sub which is cardioid, which is driven off one channel of an amp. We're not using DSP, we're using PSP, we call it affectionately, plywood signal processing. And you have a very effective system in terms of the amount of amplifier channels and DSP on the back of it. So this stack, you could add another sub with 2 tops, could be driven off one dual channel amplifier. And say these go 139 dB SPL peak, these are 133 dB. That's quite a performance for a very minimal amount of amplifiers and DSP. That's a kind of quick 5-minute overview on why we think this is innovative.
This might be a fatuous question, but the heat management on the mid is radiated into the back chamber of the low end, and my primitive understanding is that if you warm up air, it expands. So does that have an influence on what's happening to the low end sound in that back chamber?
Honestly, I don't have enough physics knowledge to be able to answer that in a definitive way, but I could imagine the rate at which you would heat air up, this wouldn't be heating it up in a very quick moment. It would be happening over slow periods. Heat build-up in drivers that affects counter power compression on the chassis side, if you like, takes 3 or 4 hour periods to build that kind of heat up. So it's not a quick reaction thing, it's slow movement of energy out from that driver into the air.
So it's unlikely to colour it in a recognisable way?
That would be my gut reaction.
Steady over time.
I couldn't say for sure, but my gut reaction would say that's not an issue.
You described how you're using the bandpass to delay the lows to the mids.
Yep.
How are you time aligning the HF to the mid, which looks to me like it's behind the HF drivers?
Again, because we have total control over this mid-range driver in this concealed unit, and the HFs as well are in a concealed unit, we can kind of play with that phasing relationship of those and be very accurate with that. And also in the HF region, where the crossovers are dealing with much shorter frequencies, where we can get over issues like that by simple things like polarity inversions and stuff. In the lower end, where we're dealing with much longer frequencies, longer wavelengths, and where we probably have quite wide crossover regions, it becomes more of an issue to deal with that kind of stuff. But we inherently have kind of control over all these acoustical parameters within the cabinet without needing the DSP to fix them alone, if you like. We still have DSP available to us in the amplifier, but we use that DSP over a cabinet as a whole.